Hi, hi everyone. This Hi everyone. This is your TA Kaijing. In this video tutorial, I'm going to show you how to develop control system with HYSYS, which is a critical part of your project. I'm going to very briefly describe the steady-state design and simulation, which will be the first part that you need to do in HYSYS. This part is relatively straightforward, so I'm not going to show you in details through a video tutorial. But you will follow the steps very closely in the handout described from control system developed with HYSYS, which is already uploaded under the project file on Blackboard. I'm going to quickly remind you that since there is some differences between the newer version of the HYSYS and the old version of HYSYS, you will add when you go into the HYSYS through a new window, you will specify the flu packages and the component list under the properties menu on the left, as my mouse is showing on the screen. The component list will allow you to add what molecules or compounds you have in the system. And also, the flu packages, you will specify an RTL model that will pertain to our system. And after you finish that, you will go into the simulation menu, which this is a place you start to set up your steady-state flow sheet. Under the flow sheet modify menu, you can find the models and stream button. This button will allow you to open up a menu that allow you to find specific unit ops that you will link together to make your steady-state flow sheet. So good luck on setting up the steady-state part of your HYSYS simulation, and let me know if you have any questions through email. One final word is make sure you type in the units correctly. I know by default you will have the unit in SI, but some of the numbers are provided in PSI, especially the pressure, which you need to type in that correctly or things wouldn't work out. Okay, now I'm just going to jump to the second part of the handout, which is on page 11. And in this section, you will start specifying the dynamic characteristic of the equipment, which that's very important to start your dynamic simulation later. So when you look at the HYSYS window, you will open up the flash ROM operation, and then you will have the window pop up that allow you to specify the volume, the diameter, and the height of your drum. So as specified in the handout, I will type in the numbers provided in the handout, which diameter will be 1.5 meters, and then operating level will be so I will type in the diameter as 1.5 meters, and then I will type in the height as 2.5 meters, and then you see the volume is computed automatically on the top. Now we go into the dynamics tab, and then we specify the liquid volume percent as liquid level volume percent as 42. So we see the liquid volume percent here, and then we specify as 42. This will be somewhat a heuristic number depending on what the system you have, but by following the handle, I choose 42 here. So by entering 42, we finish this step, so we can close off this window. And then the next step is we need to size the control valve. So we double click on one of our control valve, which is the feed valve, and then we, as prescribed in the handout, we let the valve opening 50% by default, and the CV button chosen, and the linear ratio button on. We now click on the size valve button, and then you that should give you a CV value, CV value here. And then we will do the same thing to our vapor valve, and we make sure it's 50 while opening, select CV, linear, and then size valve, and then we should have our number around 600, and then that will be good. And then we close off this window, we open the liquid valve, and then we go into 50, CV, linear, and size valve. We have number 260, so that's very good. And then we'll close off this window. So the next step is to specify the control valve dynamics. So in order to do that, we will go into the integrator. So we go into the integrator menu, and then will be a window pop up, and then we will, at first we need to select the go into the options and make sure we enable the static head contributions selection. I know this menu looks a little bit different than the menu provided in the handout, but I think we only need to worry about the first one, and we can just leave others as default. So after doing that, we will specify the dynamic response of the control valve. So don't click on any of the buttons below, just minimize the integrator menu, and then you can double click on the feed valve, and also the other two valves, and then make sure you go into the dynamics tab, actuator, and then change the mode to first order using the number provided provided in the handout, which is an actuator time constant of 5 seconds, and then the valve thickness time of 3 seconds. And then we can just leave and the actuator linear rate, we can change that to linear rate. We can either we will change that to the same as in the handout, which is 0.0201. Yep, 0.01. And then and that will finish this step, and we should do the same thing to the other two control valves on our PFD, which we just close off this window, and then we go into dynamics, actuator, 5 seconds on the actuator constant, and 3 seconds on the valve thickness constant, and then we just put in 0.01, and then I'll be finished this one, change to first order, and then close. The liquid valve, actuator, first order, 5 seconds, 3 seconds, and then 0.01. Okay, and then everything is good. And now we are just going to we are just going to fire up the integrator and go into the dynamics mode. So by doing now, we click on start button down here, and then it will say the dynamic assistant identify items which needs action. You click on yes button, and then the this software will automatically help you make some changes to your dynamic model flow sheet, which that will be suitable to the dynamic model. You just keep them as default, and then click on make changes below, and then you just finish, and then you and then you will click on the dynamics and then the dynamics mode button to switch to the dynamics mode, and you click on yes. So by doing that, that concludes that we already switched to the dynamics mode, and you can verify that by clicking on format flow sheet modify, and then you go into the dynamics PF specs on the right, the most right down selection, change from default color scheme to dynamics PF specs. And if you see the green line going to the feed well, and then the light blue becomes the drum feed, that means you already switched to the mode correctly, dynamic mode correctly. And that concludes our first part of this tutorial. In the following videos, I am going to show you how to start your dynamic simulation using